Hello, class. Well, today we're going to be starting with statistics. I'll move that right up there where it's out of the way, and we'll be covering statistics tomorrow. Use your time wisely because several of you do probably have things you should be turning in. It's near the end of the semester. I know you guys are kind of burnt out, but use your time wisely once you finish with today's stuff. You shouldn't just be kicking back, relaxing if you have stuff to do. So for today's warm up, is we're looking at the amount of caffeine per cup. You see that for decaf coffee, we have 3 milligrams, 19 milligrams in hot chocolate, 20 in green tea, 27 in a shot of espresso, 40 in a can of cola. Coca Cola, most cans are like this. There's some that are really high in caffeine. Black tea is 45. Some energy drinks have 85 milligrams, and I know a lot of people drink those. Instant coffee is 82, and brewed coffee 95. So, this is just doing a quick search on caffeine and drinks. Could there be deception here? More than likely. So let's have a look. So we're going to be looking at intro to statistics, stats to the next 2 days, today and tomorrow, and how they can lie to you with stats. Represent data using dot plots and interpret data displayed in dot plots. So we're just focusing on dot plots today. Warm up done. Vocabulary, we're going to have a look here in a second, look at the discussion, and you'll have the first packet in the folder. So, dot plot, cluster, and outlier are the three review vocabulary words that we're going to be looking at today. So, but for more bit of review, we're going to be looking at mode, median, mean, and range. So, mode, I need to fix the slide in the future, is going to be what happens the most. As you see in the first data set, 2, 4, 2, 3, 5, 2. 2 happens 3 times. 2 happens the most. Second set, 6, 7, 8, 7. 7 and 8 happen the most in that one. Mode, most. For the median, we're going to be looking for the middle. So it's always a good idea to range the data from smallest to large because it will help with several things. And then just count in by how many? 1, 2, 3, 4. 1, 2, 3, 4. The mean is probably the most annoying one because you have to add everything up and divide by the amount of terms you have. Okay, so that takes the most work. Finally, we have the range. It's basically subtract the smallest from the largest. And this is where arranging from smallest to largest also helps because you just take the smallest number, the first number, and the very last number, subtract the smaller from the bigger. Good to go. So, what's the mean, median, and mode and range of the following? First things first, you realize that, hey, we're not in correct order. 89 and 42. 42 is looks to be the smallest here. So what you could do is just grab that 42, put it here, cross it off, and then keep doing that as you arrange from smallest to largest. So we want to arrange in order. 42, then we had 80, then 82, then we had 186, and we found another 86, 87, 89, 90, and 96. So we have our range from smallest to largest. So that'll make the rest of these really easy. So we have 9 terms, so we want to count in by 5. Doesn't matter which way we count in by 5 because we have 2, 4, 6, 8, 9. So 2, 4, 5 lands on the Sun 86 going from right to left. 2, 4, 5 left to right, still 5. So we see that we have that 86. Range is small from large, 96, 42. So 96 minus 42 gives 54. Mode, so what happens the most? Well, we see that we have two 86s. So we can have a repeating number, in this case 86. Mean is sum, we add up every single term, so we might want to use a calculator, and then we divide by 9. So when we add every single term, we get 738. 738 divided by 9 will get us 82. That is our mean, our average. Does that kind of make sense? Well, due to this outlier, it seems to take the data and pull it down. So of course, it's going to bring the averages lower down over here. So that does make sense in this case. So let's go ahead and have a look at this one. Again, we have 38, 35, so it tells us we need to arrange our data. So we arrange our data from smallest to large. In this case, we have this 33. How many do we have? 2, 4, 6, 8, 10. That's going to change some things. Since we have 10 numbers, we have to divide the fifth and sixth. So 2, 4, 5, 6. So we're looking at that 36 and 37 from right there. We're going to add those two together, get 73. Divide by 2, 36.5. The mode. What happens the most? We have two 36s, so that would be our 36. The range, 33, 41. Subtract the 2 and get 8. Notice how this range is a lot smaller than the last one. So what's that tell us what's going to happen with our average? The average should be more centralized in the center, or the mean. So we get 369, divided by 10, we get 36.9. Notice how this time the average is pretty close to the mode, which is also pretty close to the median. That's expected because the range is quite small, actually. So that's something to pay attention to. Okay, we'll see this particular dot plot again. But what it is a graphic display using dots, and it's simple to scale, and it's compare frequency within categories of groups. It's useful for relatively small data sets, and displays clusters, gaps, and outliers. A cluster is a strong area of data, as seen right there, as it kind of tapers off here, so we would say the cluster is more right there. Gaps are areas of no data, as right here. And then we have an outlier, or this term right here, because it deviates greatly from the rest. Kind of like how we had that 42 on the very first data set, that would be considered an outlier. All right. So dot plots continued. Frequency, the y-axis, as you see, there's no y-axis over here. It's not needed, but you can count to find the frequency. In other words, we can just count 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 10. 4, 8 minus 1 is 7, 7 minus 1 is 6, 6 minus 2 is 4, 4 minus 2 is 2, 1, 3, 1, 1. So it's very precise, no data is lost, and it's easy to interpret. No data is lost if you keep the data, but you could fudge on the data. It's large data sets take time, is very time consuming and hard to read. So if we had to say 1,000 dots, you would have to be like, okay, how many dots do we have here? And you're only limited to 2 data sets using dot plots. So it does have its uses, but it also has its drawbacks. One of the many ways of being misused. Notice how this is just talking about plant heights, another graph I found online. And ask yourself this question: is there an outlier? Well, we have a data cluster over here, a data cluster over here. This vaguely could be considered an outlier for right now. But if we were to accidentally have something happen to our data set, like, I don't know, let's just say some of it was corrupted. Now, is there an outlier? Yeah, the 7 is definitely an outlier now because of our our data just disappeared, but who knows? So you could accidentally leave off some data and interpret the data to make it so it suggests what you want. And that's the main thing about statistics is you can force the data to say exactly what you want. That's why they love to quickly display the graphs and stuff on the media and saying, oh, look at this. This is terrible. All right, but let's interpret the data set for today. How many of weight? 9 kilograms. So we look for 9 right here. 1, 2, 3, and count. What's a maximum weight in kilograms? The 16 is the maximum weight, but it could be an outlier. What's the least weight? Well, 0. We have 3 of them. And is there an outlier? As stated, that 16 could be the outlier. Maximum number hours spent on homework. Okay, well, we look for the maximum hours, 9. Minimum number of hours spent on more homework is 0. I'm pretty sure some people could relate to that. And the averages on homework. So we add up all our terms, or we can just multiply. We have 1 times 0, 1, 2, 3, 4, 5 times 1. So let's just go ahead and go through that. We count how many we have first, which is 25. 5 times 1. Notice that we have 4 2s, we have 3 3s, 4 4s, 2 5s, 3 6s, 2 8s, and 1 9. Add those up, we get 91. Now we have to divide that by 25. So think about logically for a second. Don't put in the calculator quite yet. Think about it logically. 25, 50, 75, 100. So we can say that this definitely goes in 3 times. So the average would be between these two. And for this data set, does that make sense? The average should be between those two. It should make some sense because let's look at the median because we don't really have a strong outlier in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 12 and 13. So right here is 3. So the median is 3. The averages should be pretty close because we don't have a strong set of outliers or data over here. It's slightly skewed, which we might go about in the future. So if we click on this Desmos, what we'll get is dot plot stuff. So to create a list of numbers in Desmos, you have to type the following below. So basically D and M, random K. You have your choice of M, and K. You can even name D differently. So for instance, if we were to say 1 and say, I don't know, how about 25? And we're going to say that we want a random 50. Okay. So now we have D is a 50 element list. So now we're going to write dot plot for D. Dot plot D. So the interesting thing about this is you can come up here and actually hit randomize. And every time you hit randomize, it changes your dot plot. So if you really wanted to actually create a list, you could put them in manually by saying like 2, 3, 4, etc. But you can. This is a way you can actually play around with Desmos and actually create the dot plots. You can also create histograms and other things like that. But let's go ahead and jump back to here. So how are they different? How are they the same? So this is just a brief look at histograms. If we're looking at it using linear bins, so this is like, we're going to go a little bit more in detail about this tomorrow, but this is how another way they can lie with histograms easily. This is the same data, but they're using linear bins and linear scales. So you see 0.5, 1, 1.5, 2, etc. 0, 100, 200, 300. But now they're using powers instead. So notice how by using powers instead, they can create the bell shape, they can create a spike over here. So they can easily just change how they display the data using the same exact data to make it more emphasis like this. All right, we'll go in more detail about those tomorrow, but you should have everything you need for today. Again, use your time wisely. Have a nice one.